Good morning. Welcome to Morning Coffee Live. Sorry about the couple days miss. Had some technical troubles on Friday, setting up a new mic and just getting over a cold. So please bear with me and forgive me if I sniffle a little. I just want to jump in and talk a bit about AI, specifically about hallucinations and a approach to reduce them. Hallucinations are something that it's fascinating. I mean, it's hallucination. Let's start with what it is. A hallucination is when you see, do, say, speak, create something that doesn't exist, right? Um, Look up the actual definition of the word. I'm not even hallucination. Not even sure what the formal definition is. Let's see. It is an experience involving the apparent perception of something not present. And AI has been getting famous for. Um, Hallucinations are something most people never talk to about or spoke about in general at all that often, unless they were referring to drugs. I guess is probably a popular term in the '70s. But these days, nobody ever really talked about hallucinations in any form whatsoever until AI hit the scene about 2 years ago. And now we've been seeing hallucinations popping up in the news. And here, let me give you a quick run through of some of the headlines. Okay, take here. Why RAG won't solve generative AI's hallucination problem. Alembic debuts hallucination-free AI for enterprise data analysis and decision support, a framework to detect hallucinations in the text generated by large language models. Oh, that's actual hallucinations. And this is how we're used to seeing them. Hallucinations got worse. Man shot by police. Had family calls 911 for a wellness check. That's the context. Historically, we've always seen hallucinations and not in relation to AI. So we have, okay, I'm not interested in reality. AI artists reflect Art Hollow and creative cloning hallucinations in the future of art. OpenAI to be in trouble over ChatGPT's hallucinations about people. Hallucinations draw EU privacy complaint. Just for the heck of it, let's go ahead and make it AI hallucinations and then go just keep it a little safer, hopefully. And let's go to, oops, let's leave news. Let's go to Google. Just type in AI hallucinations. Give an example of what's the type of stuff going on. Okay, good ones. Well, if I sold 10 products A and it was $5 per unit, I sold 15 products B and it was $3 per unit. I sold 8 products C and it was $7 per unit. How much in total did I make? Okay, let's just do this real quickly. That's 50 plus 45, like 95, and 56. We get 95 plus 56. That's okay. So the total amount made would be 140. This is calculated involving 10 by 5, 15 by 3, and 8 by 7. 10 times 5 is 50, 15 times 3 is 45, 8 times 7 is 56. Right, bringing us to, what is that, 101. Give it 141. That's incorrect. So this is an AI hallucination. It didn't do the math right. 50, 100, 45, 51. 151, it says 141. Why is it messing up? Well, why do AIs hallucinate? That's really the question you need to ask. What makes an AI hallucinate? Well, how an AI works is the algorithms are predictive. It takes a word or a phrase and it takes what you put in. Let's say it's a phrase, right? Whatever you ask into, say, ChatGPT, and it breaks that down into smaller segments. It breaks it from a sentence to, say, a phrase to individual words. It then goes and tries to match those based on the context that you put in to what a response would be. And it uses predictions on what word should come next. Well, one of the things when you're predicting is an AI doesn't truly understand, doesn't think, right? So it doesn't truly understand necessarily what a topic is or what the answer should be. It knows what should come next. Well, the thing is, if it's off on what it is that, if it didn't fully understand what it is trying to produce, you could end up in a situation where the AI thinks effectively based on its algorithms and its predictions that the next thing belonging in a sentence may be something that doesn't relate entirely. And then what happens is after you've added that next word into its response that say doesn't relate because it didn't understand that even though this word makes a lot of sense to come next in the sentence, it doesn't fit this context. Well, it's now using that word in its next prediction for what comes after that, and you'll get off on a tangent. That's what's called a hallucination. And it's where you completely miss the point of what was supposed to be going on. Well, people are just starting to find a solve for this. And one thing that you're starting to see popping up is RAG is just an acronym for Retrieval Augmented Generation. It's one of the most basic and useful methods of training AI models. How RAG works, Retrieval Augmented Generation, is it allows you to upload your own data into a large language model. What it does with that data is it takes your data and it chunks it in different size chunks and it vectorizes it. What that means is it takes those chunks of data and actually stores them in vector storage in proximity to the processing power you're using. And it actually spreads out the data and it now has a way to reference stuff that you put into it. And it does that by taking it apart, analyzing it, building it into chunks, blocking in there, and using it just like it would its pre-trained data, but on your new data. And what makes it retrieval augmented generation then is when you ask for something, you can now have your large language model even either use a standard data set like it normally would, use its full foundation model or large language model data set that's been trained on, or you can have it reference the materials you added to it. You could do that through RAG, retrieval augmented generation. You can also have it do a combination of both. There's also models out there where you can let the model decide whether it should use its standard data set or if it should use your specific data set you uploaded. Where RAG helps with hallucinations is it gives it a reference material to use beyond just what was in the large language model itself. So you could add your 1P data, for example. What's the advantage of that? Well, it gives you something to check against. Instead of just saying, okay, here's the entire internet of data, that's effectively what's been into these models already, you're giving a specific data set and saying, use this. In doing so, you can tailor that data set for very specific functions and purposes. And then using retrieval augmented generation, your AI can now reference that data. It can also test against it for validity. Where it's being used right now is to solve hallucinations, but there are some issues there. Let me go ahead and bring this back up. Here's an article that came out just a couple days ago. Why RAG won't solve generative AI's hallucination problem. And what's going on is we have companies coming out here saying that we can get around hallucination. Well, we can start to, but I don't think fully yet. So why won't RAG solve generative AI's hallucination problems? Well, hallucinations, lies generative AI models tell basically are big problems for businesses. Yes, they are. Because models have no real intelligence, are predicting words into speech, music, and other data according to a private schema, they sometimes get it wrong. This is what I was talking about. This is where it's using predictive modeling to determine what word comes next. The private schema, that's just the algorithms that the AI is programmed with that make it function. In a recent piece in the Wall Street Journal, a source recounts an instance where Microsoft Generative AI invented meeting attendees and implied that conference calls were about subjects that weren't actually discussed on the call. So, how does that happen? Well, how that happens is that it doesn't know any better. It's an AI. So, when it's looking at attendees, let's say for an upcoming call, like let's say you tell an AI, schedule me a call to discuss this. If the AI determines there's a correlation between one person and this call, even if that person's not necessary for this call at all, it might just add them in there and say, yep, they should be on this call because it found a reference to their name, let's say, in conjunction to whatever the topic may be. Well, These companies are now coming around and saying they can do better. Using RAG, okay, here's how our, here we go. As I wrote a while ago, hallucinations may be an unsolvable problem with today's transformer based model architectures, but a number of generative AI vendors suggest that they can be done away with, more or less through a technical approach called retrieval augmented generation or RAG. Here's how one vendor, Squareo, pitches it. At the core of the offering is the concept of retrieval augmented LLMs, or retrieval augmented generation, embedded in the solution. Our generative AI is unique in its promise of zero hallucinations. It's a heck of a claim. Every piece of information it generates is traceable to a source, ensuring credibility. Okay, so they're backing up the claim by saying that every piece of information generated is traceable to a source. That does not ensure credibility. Why it doesn't ensure credibility that I see right off the top is twofold. One, you can cite something and be wrong. So therefore, just citing a source doesn't ensure credibility. For example, let's see. Okay, here's where citing a source can mean that you may not have credibility, and it's effectively it's misquoting, it's misciting. It's something every college student has done intentionally to cite a source to write a paper, but AIs don't do it intentionally. They just do it because it's what they think they're supposed to do. Here's an example. You have a source that says you sold 10,000 products this month, right? And that's loaded up to it. And so then you go and ask your AI, um, how many products we sell a month. It's going to come back and tell you 10,000. You're going to go, see, it's accurate. It's going to cite that source and you're going to see it's credible. But now, what happens when you say, how are sales doing? The AI might come back to you and say, sales are doing incredibly. We have 10,000 sales a month, and it can cite that. Well, what it may not know is 10,000 sales a month good or bad? What if 10,000 sales a month is your company history low? Well, it's not good that you have 10,000 sales a month. Then it's bad that you have 10 sales a month. And you may want 100,000 sales a month, right? So just because you can trace the information to a source doesn't necessarily give it credibility or mean that it's not going to misconstrue your data. Here's a similar pitch from SIFTUB. Using RAG technology, a fine-tuned large language models with industry-specific knowledge training, SIFTUB allows companies to generate personalized responses with zero hallucinations. This guarantees increased transparency and reduced risk and inspires absolute trust to use AI for all their needs. Once again, zero hallucinations I find hard to believe because AIs don't understand what they're doing. So even if you're using RAG and you're referring back to new data, if you're using, maybe you have some advanced prompt chaining that's checking it all. It doesn't mean you're going to get zero hallucinations. You might reduce them, but I find it hard to believe you get zero. So let's see what this author says about it. RAG was pioneered by data scientist Patrick Lewis, researcher at Meta and University College London, and the lead author of the 2020 paper that coined the term. Applied to a model, RAG retrieves documents possibly relevant to a question, for example, a Wikipedia page about the Super Bowl, using what's essentially a keyword search and then asks the model to generate answers given this additional context. When you're interacting with a generative AI model and you ask a question, the default is for the model to answer from its parametric memory, i.e., the knowledge that's stored in its parameters as a result of training on massive data from the web. This is the standard function of like ChatGPT. Its parametric memory is what it's pre-trained with. In GPT, pre-trained is part of the um, a research scientist at 812 found her focus on yada 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 explained, but just like you're going to give more accurate answers if you have a reference like a book or a file in front of you, the same is true in some cases for models, right? And that's the idea of RAG, is you give it reference material to use. RAG's undeniably useful. It allows one to attribute things from a model generates to retrieve documents to verify factuality and avoid potential copyright infringing regurgitation. Great point right there is AI has been trained on just massive amounts of data, and a lot of that data is owned by other people. We are already seeing multiple lawsuits popping up, predominantly from some news organizations that have sued OpenAI and a number of other companies, saying that, hey, you trained on all of our data that was copyrighted, trademarked, etc., without permission. And now that data is being reproduced, and we deserve to be paid for that. Well, another way to avoid that and using that data that might belong to someone else is through RAG, and that is if you upload your own data in and you build it into a RAG system, and then you limit the model to only reproduce responses that come from data you loaded, you can then reduce or remove the likelihood of plagiarizing or copyright infringement because you'd be going off of your own data. Also, it lets enterprises that don't want their documents used to train a model, say companies highly regulated industries like healthcare and law, to allow models to draw on those documents in a more secure and temporary way. So this is an interesting thing. It also talks. It's I'm going to call it the difference between RAG and training your model. When you use RAG, the documents that you upload for doing the retrieval augmented generation do not have to be long term. They can be short term. They can be uploaded, parsed, put into vector storage, used, and then deleted again. So you don't need the data to live on servers long term, just long enough to be accessed. Advantages and disadvantages of that. Advantages are it lets you be more secure with your data. You don't have to leave it all on a server somewhere. Disadvantage is every time you run it, you have to make sure that data is put into vector storage and you have to pay the storage costs associated with that and everything else. There's some costs involved in time, but it also means you have to redo it every time and you're going to have issues possibly of consistency over time because every time you reload the model, it's going to break it down a different way based on the algorithms. The same way if you ask an AI the same question twice, you get two different answers. I would assume you're going to run into the same issues with uploading the same data twice, of getting two different cuts of your data or looks at your data, if you will. But once again, it does give that advantage for not wanting to use your data to train a model. Second thing we haven't touched on yet is training a model. Training a model is similar to RAG. And the idea, though, is instead of putting the data into vectorized storage for short term retrieval, what you do is you actually train your model on your data sets in a more long term method, and you actually program it into where your data becomes part of its parametric memory, meaning that when you ask it a question, it can use your first party data the exact same as it would its pre trained data. And it's not necessarily going to put preferential treatment to it over anything else, and that you could have it do so if you'd like. But it's just giving it more data to work from. So when you train a model, you are giving the model the data to use at all times to build on, to use to even do things not directly related to that data. And you're putting it into its overall memory store, if you will. You're training the model. Whereas when just RAG, you're not actually training the model. You're just temporarily putting the data into vector storage around the model so that it can access it, it can read it, it can look at it, but not putting the long term storage. Think of RAG as almost using RAM as short term memory to store stuff to be used. Whereas training a model, you're basically going to put yourself into long-term memory, into ROM, right? To where it can be used through time, um, but it's not going to be as focused necessarily as it would be with the RAG data. You can also do both. Train your model on first P data, and then you can use RAG to put in data sets used for specific instances, or let's say more up to date for a specific thing you're doing. You can then add that data on top, use that for retrieval augmented generation, but still have a trained model that's trained on your data. That would probably give you the best of both worlds. Moving on. RAG certainly can't stop a model from hallucinating, and it has limitations that many vendors gloss over. I'm going to say I'll probably be agreeing with this section. Let's see if he goes farther than that. Widen says that RAG is most effective in knowledge-intensive scenarios where a user wants to use a model to address an information need. For example, to find out who won the Super Bowl last year. In these scenarios, the document that answers the question is likely to contain many of the same keywords as the question, e.g., Super Bowl last year, make it relatively easy to find via keyword search. Once again, that keyword search matters due to how, when you're doing a RAG build, how the data is stored in vectors and how it's parsed, and with the tokens, the keywords are very important for it to be able to figure out what should come next in its predictive. Things get trickier with reasoning intensive tasks such as coding and math, where it's harder to specify a keyword based search query the concepts needed to answer. Ooh, okay. Things get trickier with reasoning intensive tasks, such as coding and math, where it's harder to specify in a keyword based search query the concepts needed to answer a request, much less identify which documents might be relevant. So, yes, in reasoning intensive tasks, it is harder to specify keyword based search queries because there's less keywords. Even with basic questions, models can get distracted by irrelevant content in documents, particularly in long documents where the answer isn't obvious, or they can, for reasons as yet unknown, simply ignore the contents of retrieved documents, opting instead to rely on their parametric memory. These for reasons yet unknown. I don't know what those reasons necessarily are either, but my guess is it's just a matter of the model finds something else first that satisfies its requirements to go to its next step. And so it's going, okay, I need to figure out the next thing and say, oh, found it. It may never get to your document just because it's already found an answer. Maybe it's not the best one, but it decided it was good enough. It ticked the box, if you will, and ran off with it. RAG is also expensive in terms of the hardware needed to apply it at scale. And so once again, RAG takes your data, chunks it into smaller pieces and stores in vector memory. Doing so is not cheap. Vector memory is expensive. It's very fast. It's actually physically located near the processors to reduce latency, things like that, as a general rule. And so when you are working with vector memory, your costs go up. If you're doing a small data set, you're just uploading, you know, some documents or, you know, 20, 30, 100 pages of data. It's not that big of a deal. Yes, you're going to have to pay the storage costs and the access costs, et cetera, but it's not going to be huge. But when you start running into large data sets, if you're a large enterprise company and you have, tetrabytes of data, terabytes of data, your costs of trying to build it into RAG is going to get prohibitive fairly quickly, or if not prohibitive, at least extremely expensive. And you're probably going to hit the point where just training a model on your data is going to be better than going straight RAG and using RAG for more short term approaches. Because once again, it's an expense. And let's see what he says. That's because retrieved documents, yada, 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 have to be stored in memory and compute time. Yeah, exactly. Memory and compute. The technology is already expensive for the amount of compute and electricity for basic operations. When you start building large RAG models, those numbers can go up very drastically and very quickly. Some of these efforts involve models that can decide when to make use of the documents. Yep. We're pretty good at retrieving documents based on keywords, but not so good at retrieving documents based on more abstract concepts, like a proof technique needed to solve a math problem. And that's why most foundation models now have agents that are built that specifically can do things like math. So when a math problem comes in, you task a math agent with it because it's specifically tailored. Researchers need to build document representations, and search techniques that can identify relevant documents from more abstract generation. I think this is mostly an open question at this point. So RAG can help reduce a model's hallucinations, but it's not the answer to all of AI's hallucinatory problems. Beware of any vendor that tries to claim otherwise. Agreed. I don't think there was too much of an argument for why RAG won't solve the hallucination problem in this article, but I do agree with the conclusion that it won't solve generative AI's hallucination problems. They're saying it won't solve it because sometimes it just skips the data and it's cost prohibitive expensive. There weren't any other points in there. I think you're going to run into larger issues too, though, and that is you put enough RAG data in there as well, and you're going to run into the same issue you run into with the large language models, and that is going to have enough data to where it's going to get confused. It's going to pick something, it's going to run with it, it's going to think it's correct, and it's going to produce a hallucination, a false result. Where you need to be careful if you are using RAG is you do not want it producing a false result that you believe to be a real result due to the fact that you used a RAG model and it cited its source. Just because it does so does not guarantee that your data is accurate. Don't forget that data can be misused. They say 99% of all statistics are made up, right? Well, even if you don't make up the statistic, another one that goes right along with that is 99% of all statistics can be used to argue any side of any problem. And it's true. It's very, very simple to manipulate statistics to say what you want it to say. And you can use the same statistic to argue two sides of the same problem as a general rule. And the reason is statistics aren't inherently good, bad, or otherwise. They're just statistics, they're numbers. It's just telling you something statistically, you know, relevant, right? And how you argue that, the story you tell around that is really what's going to matter. So if your AI model is telling you the story, is writing the story for you, make sure you're verifying it and not just be taking it for granted when it cites its source as, internal company such and such from last year, you going, yep, it's from our data, it's definitely accurate. Make sure you're paying attention because AIs do hallucinate. And at this point in time, we have gotten to the point where um, AI hallucinations are not only are they an issue, but they're affecting business already. And we have companies now popping up saying they give you hallucination-free AI for enterprise data analysis. Be careful. I am not going to believe anyone to be hallucination free till I see it at this point, just because no one's had a peek yet under the hood of these AIs to understand how they're actually functioning to where we can guarantee that something like using a RAG approach is going to solve the hallucination issue. I highly doubt it will. I think it might mitigate it, not solve it, but I think it's also going to create challenges of people thinking they're going to be in a much better spot with their data and still be having their AI's hallucinating and lying to them and then not realizing it because they're saying, oh, well, it's a RAG model and it cited the source. And I think it's going to lead to even more complicated problems in the future as well. So something to keep an eye on. But yeah, it's all over the news. Hallucinations, why it makes stuff up, what's being done about it. RAG's one of those things being done about it. There's all kinds of stuff being done about it. There the algorithms that are trying to understand it better. The interesting thing with AI is most people it is a black box. Nobody fully understands how it all works yet. And my understanding is that even a lot of the devs don't fully understand the creation they have made, and it does stuff that surprises them too. And part of me says, well, that's great programming. You made such a complex program. You don't even know what you're doing. And part of me says you might have wanted to document your code a little better to follow the process. But either way, at the end of the day, AI hallucinates. We know that. There are methods being developed to try to mitigate those hallucinations. I don't think removal is here yet. It will be eventually. But for now, it is something to be aware of. And be very careful when you're using AI. If you hold up AI hallucinations as fact, and they might sound very legitimate, at the end of the day, you're going to be the one who ends up looking stupid because you didn't prove your work. So keep an eye on your AIs, make sure they're not hallucinating. If hallucination is something that worries you, you're in a field where what you're producing from your AI really does matter. Using other tools such as retrieval augmented generation or other solutions that are going to be popping up might be helpful. Don't count on it. The human element is not obviated yet. It is absolutely needed. There needs to be someone checking the AI. And right now, that's left to us. Still love AIs checking the AIs, but for now, keep an eye on it, see what's going on, and make sure you don't get yourself into trouble by putting out AI hallucinations as fact when, you know, there's ways around it, such as read the content produced by your AI and then make a decision whether or not it's worth using. So yeah, I talked a bit about AI hallucinations, RAG. AI hallucinations obviously an issue. RAG will not solve all of the issues with it, but might help. And it's not only AI that hallucinates; drug addicts do it too. Don't forget the 70s. In defense of AI hallucinations, looks like there's people fighting on the good fight for AI as well. I wonder if AI wrote this article for Wired trying to defend itself. Either way, how to mitigate it for enterprise success, right? There's articles coming out, people are talking about it. It's a thing. AI hallucinations are real. It happens more often than you realize. I've used AI for writing drafts of many, many things. I would say in at least 10 to 15% of my outputs, I get some kind of hallucination where an AI just makes something up, even when it's specifically told not don't to use don't use anything that you can't back up as verifiable fact. It'll make stuff up. So read carefully, watch what you're doing, and yeah, enjoy. And I guess that's it for today. Ragging on AI. Have a great day, everybody, and